Today we are going to discuss derivation of kinematic equations of motion in graphical method. In earlier class we learned about through calculus method. Today we learn through graphical method. Suppose consider a body moving with initial velocity u. Due to its acceleration, its final velocity will be changed to v. Clear? During this time t, it will body covers a distance that is s. Then we plot the vt graph like this. The body already started with some initial velocities. You make it point here. That is, you have to draw one linear line. You get the graph like this, linear. That is AB. Clear? This is the vt graph. Actually, in earlier class we learned that is the slope of vt graph at any instant. For example, this is a vt graph. This is the time. This is velocity. The slope at any instant, at this point, at this point, and at this point, and at this point. The slope of this vt graph at any instant gives the magnitude of acceleration at that instant. In the sense, what actually means vt graph slope gives the acceleration. We know from this, according to this vt graph, we have to write the values. Initial velocity u is equal to OA. Final velocity, that is dv. From here to here, this is final velocity. Final velocity. Again, time t is equal to OD is equal to AC. Same, both are equal. Time t. BC, you want only BC in the sense this much distance means total how much this is B. From here to here B. From here to O to A, this is U. From O to A, this is U. From D to B, total B. We want only this part. How can you get? That is BD minus OA. What is BD? That is B. Minus what is OA? U. That is equal to V minus U. You get the region of this. Only this part you get V minus U. Here V minus U. Here BC is equal to V minus U. According to VT graph, at any instant the slope what will gives here? Acceleration. So here acceleration m is equal to tan theta is equal to bc by ac. In mathematics, you how can you calculate slope with the help of tan theta? Clear? Denoted with a symbol that is m. What actually this sentence explains? At any instant, slope vt graph gives acceleration. A is equal to. See, what is tan theta here? Here you get the slope of this vt graph linear line. Here you get the theta. Clear? See, tan theta is equal to opposite side. This is bc. Adjacent side this is AC. BC by AC. Acceleration A is equal to what is BC? We get B minus U divided by what is AC? AC in the sense we get OD or AC both are equal. See, OD or AC both are equal. That is T. Just cross multiply T. You get AT is equal to V minus U. Just send this minus U to left hand side. You get U plus A. That is equal to V. Therefore, finally we get the first derivation, first kinematic equation, that is V is equal to U plus AT. Clear? Are you understand? This is the derivation of first kinematic equation. While solving problems, we use this kinematic equation. We want to find acceleration. They will mention the initial velocity, time like this. We can able to find with the help of these equations acceleration, whatever they ask, time, velocity, initial velocity, whatever. This is our first derivation of kinematic equation. Next class, next means we have to study about that, how to derive the S is equal to ut plus of at square. Up to this, you can stop.